Hello everyone, welcome to my YouTube channel Shilpa Data Insights. With what is the workspace, what is a cluster, and all these things. I will give you a brief introduction about it. So let me just move on to the next slide. Okay, so the prerequisite is there for this particular workshop. The prerequisite is you should be knowing a basic of PySpark and basic of SQL along with the basic of Python. If in case you don't have any of these basic knowledge, you can definitely go ahead with a reference link that I've shared. You can watch that basics of PySpark at least. And the second point is how you can go ahead and create your Databricks account. So there are two types of Databricks account you can get. One is the free trial version, and the second way is to get a paid version. So in this particular session we will be using a free trial version. I will tell you how to actually set up a free version of Databricks account so that you can do a hands-on on it as well. So let me first start with what is exactly a Databricks. Databricks is nothing but it's a unified open analytics platform which is used for building codes, deploy the codes, and share the codes among users. Along with it, you can also do some analytical operations on the top of it with the help of the machine learning models as well. The Databricks platform also have a cloud storage account. So Databricks can be on the top of any cloud storage. It could be AWS or it could be Azure. And it has a unified platform. It means that you can have your cloud storage in your cloud and you can put your coding part inside the Databricks. So it's actually a decoupled kind of a thing in the Databricks account. And with the help of the Unity catalog, which is one of the feature of Databricks, you can go ahead and do a data governance on the top of Databricks account. I'll explain you all these terminologies later as we progress through the complete workshop as well, but this is just a brief about it. So the third point that we have is the ETL processing. You can create your own pipeline, build your pipeline with the help of your workflows or the job. So it's similar to any ETL process that you do in a legacy system. You can also go ahead and create your dashboards and visualization on the top of those Databricks data that you get. With the help of the Unity catalog, as I was discussing, you can also create your security, your own permissions and policies so that unwanted data is not given to a particular person which should not have the access for that. So you can have the high level security in that case. You can also create your machine learning model tracking and model serving. Along with it, there's one new feature that Databricks has introduced, that is the generative AI solution. Then let's come across with the Databricks architecture. In the Databricks architecture, if you will see, there are two planes that we have. One is the control plane, another is the compute plane. Control plane means any kind of service that Databricks provide and you don't have to manage them. Those are present inside your control plane. For example, you have your notebooks or your files that you create and you write your code inside that. So those files are actually managed by Databricks account itself. Along with it, you have your Unity catalog that I was talking about, the data governance that is being managed by Databricks account. In the compute plane that we have, it is any kind of cluster that you will be creating or Databricks provide that comes under the compute plane. So cluster means you have a node, multiple node that you create, and all the nodes in together becomes a cluster. So in that case, you can go ahead and mention how many RAM you need, how many cores of machine you need, and all together it creates a cluster. So there are two types of compute that Databricks provide. One is serverless, in which you don't have to do any much work. It's been actually maintained by Databricks. In case of classic compute, you mention how much Databricks runtime you will need, how many cores you will be needing, how much memory you will be needing, and you will be actually triggering or creating your own cluster in that case. And Databricks provides the storage account as well, in which you provide your data and keep your data. That storage account could be AWS or it could be Azure. So this is the complete architecture of our Databricks compute and the control plane. So the next that we have was Workspace UI. In the Workspace UI, there are multiple things that you will see on the left side. Yeah, so on the left side, if you will see the workspaces there, if you enlarge this workspace, there will be multiple things. There will be notebooks, there will be Git folders that you can create. I will show it on the practical as well, but in this diagram on the right side, if you will see, in the workspace you will have like this your file names and folders name. This is the repo that it is mentioning, but in the similar manner you will have the workspace files and your folders. Then if you want to do a recent checks what all files you have recently visited, you can go ahead and check it inside the recents. And then you have the catalog. Catalog means all your tables, views, all your files are stored inside the catalog. The catalog could be either a Databricks file system or it could be a cloud storage as well, like your S3 bucket. Then you also have workflows. Workflows means if you want to create your own pipeline, schedule your pipeline, those comes under your workflows. Then we have the compute. Compute means again those clusters that you will be creating. So all your clusters will be listed inside your compute. Then comes with the SQL. SQL means you have a SQL editor where you can go ahead and just query your SQL that could be inside your serverless compute. Or you can create your queries. It is like a notebook that you can go ahead and save it inside your Databricks. Then you have your dashboard. If you want to do some visualizations, you can use the dashboards for that. And the SQL warehouse also comes under that category of SQL. It is again the compute clusters that the Databricks provide, and you can go ahead and access those clusters. The next thing that you see here on the left side bottom is the job runs. Means if in case any kind of job is running, then you can go ahead and view those jobs in the real time basis, what all jobs are running and what all are completed. So I will go ahead and show you this in the practical when we are doing the hands-on of this. So then we have this cluster. There are basically three types of cluster. One is the all-purpose compute cluster. In the all-purpose compute cluster, you create your own cluster, provision it, you can create it, you can also restart the cluster, and you can terminate your cluster. The second type of cluster is the job compute. Means you are not creating the cluster, but as soon as the ETL pipeline is triggered, a compute cluster is created with the mentioned cores and the RAM. And as soon as the job is completed, the job compute cluster gets terminated. So in this, you don't have a provision to basically terminate the cluster, but it is auto terminated as soon as the job completes. The next type of cluster is our serverless SQL warehouse. In this, you can basically run all your SQL queries, and this is again on demand kind of a cluster. As soon as you start the cluster runs, and you can query any kind of SQL queries. And then once it is done, it has a timeout session that you can go ahead and provide. It gets auto terminated by its own then. Next comes is the libraries. In the libraries, again, there are two types of libraries. Libraries means the code, the package of code that you want to install or use in your notebooks. So you can either install those libraries in the cluster so that all your files and notebooks can use those libraries, or if you want the library to be specific to a particular notebook, you can do that also. Those libraries are called notebook scope libraries. So how you can actually install your library inside a notebook is similar to any installation, library installation, that you do it in Python using the %pip command. If you are installing your library inside the cluster, then there are multiple options that are provided. You can have that library source either from the workspace, like a jar or a zip file or a requirement.txt file. If you have a file which is also residing in the S3 or the DBFS location, which acts as a library, you can use that particular path as well while installing the library. Along with it, you can also use PyPy, Maven, and your DBFS location to install the libraries. So the next that we have here, it's just a small reference links that I've provided. I'll share these reference links so that later on, if you want to go ahead and see how you can set up your Databricks free account, you can go ahead and watch it, and there are some documentation. So I'll share this at the end of the session. Along with this, the next topic that we have is the Git operation. So whenever we are working in everyday use, so we are actually pushing the code to the Git. So Databricks also provide a capability to do all kinds of Git operations. So you just need to set up the Git with the help of your token, which is provided by Databricks, along with the token that is there in the Git. And once it is in sync, you can create your own branch, your local branch. You can work on those local branch and commit your changes to your Git and push the changes. The merge operation is not directly inside the Databricks. So for the merge operation, you need to go to the Git remote repository and merge the changes to your main branch or your development branch. So if you will see, the first step that you have on the first that is written here is your branch. It will show you what is your branch name. You can also create your branch from here. Once you have your branch ready and your files ready, you can go ahead and see what all files have been changed or added on the left side. So it will give you the list of all your files. Once that is done, on the right side pane, you will see what is the difference between the branch that you are trying to commit and the main branch from which you are pulling it up. So that difference, if it looks good, you can go ahead and commit the changes with the help of a commit message and commit and push button that you get. So this is the complete till now, that is a Git operation. We will look everything in the hands-on. So let me go to the website. So let me first tell you how you can create a free account in your Databricks. We have a databricks.com, and if you just search it in the Google or you just type try-databricks, this link will come up. You just give your names and all this detail and click on continue. It will ask you for, let me just do it just to show you. So if you hit on this continue button, it will ask you which particular cloud storage you want. So you can select in any one of them, AWS, Azure, or Google Cloud. Once you select it, it will just ask you to confirm your email address and your Databricks account will be ready. So you will be redirected to this page, which is community.cloud.databricks.com, and you can put your email address and the password that you have set up and sign in. Once you sign into this particular community edition, it will look something like this. On the left side, you will see, if you have selected Azure as your cloud storage, you will see Microsoft Azure. If you have selected AWS, you will see the AWS logo here. And on the right side, you will see your logo, in which you can click and you can manage your settings in this. In the left side, I was mentioning here, if you will see, the workspace is this particular workspace that we have. And in this workspace, you have all your all your email addresses, whoever have logged into this particular workspace. So I will go into my workspace. You will see some folders and files. In this folders and files, basically you can create the folders and files. I will come to this, but first let's focus on the left side that is there in the pane. In the workspace, you get this particular view. In the recent, it will show you what all recent files and folders you have accessed. Then in the catalog, it will show you what data or catalog you have. So by default, as soon as you create a Databricks account, a default catalog is created, which is Hive Metastore. Apart from Hive Metastore, also you can create your own catalog if in case it's needed. So if you go to the Hive Metastore, inside that you can create your own tables and your views. It doesn't show me anything here because I don't have the cluster yet on. So if I click on this and run my cluster, you will be able to see the data that is present inside the catalog. So let the cluster be on, then I will show you what is there inside the Hive Metastore. Then we have this workflows. Inside the workflows, we have two options. One is job, second is the job run. So the job is, if you have access to a particular pipeline, it will show all those pipelines inside your job. If you want to see what all jobs you are owning, you can click on this own by me and you will see what all jobs are owned by you. And if in case you want to create your job, you can click on this right side and create your own job. We will check this creation of the job later, but I'm just showing you and familiarizing with you how exactly the particular UI looks like. And in the job runs, you will see whatever jobs are running, it will go ahead and display you those many jobs. Then we also have Delta Life tables. This is again, if you are creating any Delta Life table pipeline, that will be showing up in the workflows. Then comes with the compute. In the compute, you have this all-purpose cluster, which is basically you are creating the cluster, you are mentioning how much DBR you are using and what is the runtime of it. If you will see here, it's the runtime version 14.3. You can select any runtime version. So this LTS means it's a long-term support and it's the most stabilized Databricks runtime version that the Databricks provide. So you can select any runtime version as per the requirement, and you can also select the worker type. So it has multiple worker types it provides. It can give you memory, different types of memory and the cores. Depending on how large is your data set, how heavy is your workload, you can go ahead and select the worker type. And you can also select how many workers you need. It could be one, it could be many. Or if you want multiple workers to be there and you want it to be a spot instance, means you are actually, if in case the Databricks needs that particular worker node, it can just give you a warning and it can take that worker node from you so that other heavy workloads can be used with that particular spot instance. Then you can also select your driver type. I've selected here driver type as same as worker. Then you can also select enable auto scaling. What does this mean is, if you have one worker node and your data set can be processed with one worker node, it will complete it with that. If it feels like it needs more than one worker node, it will go ahead and enable the auto scaling and it will enlarge it from 1 to 8. Whatever is your maximum worker node, it will just auto scale it to that particular worker node. You can also terminate your cluster with the help of what is the minimum number of activities minutes that is needed. After that, if in case your cluster is idle, it's going to terminate your cluster. So you can enable this so that you don't incur more cost whenever you are not using the cluster. In a process or a project, if you have a particular tag, you can go ahead and mention that particular tag and your value. In some advanced options, you can also use some Spark settings. Whatever Spark settings or configurations you want to put it at a cluster level, you can go ahead and mention that inside the Spark config. And if in case there's any init script, you can go ahead and provide it inside the init script. So I have this particular cluster which I have already created with runtime 13.3, and it's created with the help of UI. Therefore, it says UI because you can also create it with the help of the CLI that the Databricks provide. And if you want to go ahead and check these options, how many worker and driver, and you want to pin it that, you can also do it. Let's come with the job compute. In the job compute, as I was saying, you are actually creating the job compute, but as soon as the job completes, it's going to auto terminate that particular compute cluster so that no resource is wasted and the cost is also minimum. Then we have the SQL warehouse. Inside the SQL warehouse, you can create your SQL warehouse. In this, you just have to mention your SQL name, SQL warehouse name, and what is your cluster size. Cluster size, Databricks have provided. If you have less workload, you can select the extra small with 6 dbu per hour. If it is large, you can just select according to the requirement and you can create it. Before creating it, you can also mention the auto stop, how much minutes you want it to be idle. After that, you want to stop the SQL warehouse. And in this also, there is a auto scaling option. What is the minimum number of cluster, yeah, that you will be needing, and what is the maximum cluster that you will be having. In this advanced DBU is the Databricks runtime. Basically, it has some features. Let's say Photon is there. Photon means it will help you accelerate your data processing. So, if in case one cluster has one DBU, basically, so if it is a four core cluster, it will have 4 DBU. So, if it is large, then it has more processing power in that case. No, it's not four tasks, it's a four core. Yeah, you can have multiple tasks as well. Even if it's a four core, you can have multiple tasks in one core to be running, right? That is correct. Yes, that is correct. But again, if you are scaling it, let's say you have one cluster has, right? So it can scale up then. That is correct. 80, I have to check, but I will just check that. It should not be 80 DBUs, should be 80 cores. I'll just check that and get back to you with that one. Yeah. Okay, so this is the Unity catalog. Again, you can mention the Unity catalog if you want to enable this particular feature in the SQL warehouse. And the channel is current. The other one is preview, so we are not using this right now. So maybe this is basically right now. Databricks is still enhancing it, so this is in preview right now. Editor, if you will go, you can just go ahead and write your SQL query inside this, and you can select your catalog name. The catalog name by default is Hive Metastore, and the default is your database. So if you have your database already here, schema, you can select that database and you can query it using the SQL editor. I think I've covered all this already, and data engineering parts have job runs, data ingestion, and data delta live table. This way, we will be covering in depth later in the later slides. And in the machine learning, again, you have the machine learning capabilities as well. So now let me go to the workspace and let me show you some of the functionality that workspace is providing. So you can go ahead and import any Python or SQL file or text file from your local using the import option. And if you want to export any file, you can export that particular file. So there are three format of the file that you can use in order to export. It could be a source file, means if it's a py file, it will be downloaded as a py. If it is an SQL file, it will be downloaded as an SQL. But if you want to only use it in the Databricks, you can also download it as a dbc archive file. Then you can copy the URL and the full path of it and all. So you also have a share capability. Let's say you are creating this particular file inside your account, then this file will not be visible to anyone unless and until you go ahead and share it with your team members. So if you click on this share particular thing, it will be with your email address and admin, and you can go ahead and put any email address that you want to go ahead and share it with, or the service principal as well. If you want to go ahead and create your folder, you can click on this create folder and the folder will be created. Along with it, you can also create your Git folder. Query means it's a SQL query editor that will open up and you can query it. You can create an alert as well. You can create your dashboard. You can create the notebook, and you can create a file. So if you create a notebook, that notebook you can use it either as a Python file or a SQL file. So if I click on this notebook, it will create the file and I can go ahead and change. Right now it is the Python file that it has created, and if I download this file, it will automatically be downloaded as a .py file. So if I want to go ahead and change it to SQL or Scala, we can just select the particular language and click on confirm, and you can rename the notebook from here. So I'm just mentioning here demo one. So in this notebook, if you will see on the left side, you have your file in which you can create your new notebook, import, share. You can also schedule this from here. You can clone it, means you can clone this notebook to the same notebook in a different location as well. You can export this, you can move this, or you can also open the dbfs file browser. So if you open the dbfs file browser, inside that you can go ahead and upload any file into it. Then comes is the edit is the normal copy paste and all that you will be going ahead and you can use it. In the view, you have some important option like line numbers. By default, this is not enabled. So if you are debugging something and you want to check the line numbers, you can just enable this particular line number and it will show you which line you are actually typing in. And this is a particular interactive notebook, so you can run a particular cell by cell basically. So you can do a run all, or you can do a run selected cells, or run all above or all below. You can also restart your cluster and detach your cluster from here, or you can also restart the cluster from this particular cluster name that you have. You can detach, restart, or terminate. And yes, you can create as many notebooks and you can attach the same cluster to those notebooks. Okay, and yeah. Mhm. So the difference is, if you click on SQL editor, then you have a capability only to run that SQL editor using a SQL warehouse. You will not be able to run it using a all-purpose compute cluster. So this cluster that you see, this is a all-purpose compute cluster that I created. But if you have uh, a SQL editor, you will not be able to go ahead and run it with this particular compute cluster. For that, you will be needing a SQL warehouse cluster. So if I click on this mode, there are two clusters. The notebook, you can run it with the help of your SQL warehouse as well as general compute. But you can only run your SQL editor using your SQL warehouse. And one more point I would like to say was here, you can also explore your variable. If you have declared any variables, it's easy to go ahead and search those variables on the right side. And if multiple people are working on the same notebook, and you want to go ahead and see what was the last thing that was edited, you can go ahead and check your version history as well. So if you just write the SQL here and you write another command, it will show you in the version history that this was edited first and this was edited the next time. So if in case you want to revert the changes and you want to go back to this and remove this, you just go ahead and save this particular version of it. And along with it, the Python libraries are also there. So let me show you how you can actually attach the Python library. So first way is to basically use your notebook in order to create your Python library. So this is my notebook that I created, in which what I'm doing is I am just installing the pandas with the help of my person pip. So if I install this pandas in this notebook, this pandas is only limited to this particular notebook. If you create another notebook and you try to use this pandas, it will not work. So in order to make it work, if you want it across all the notebooks, you go to your compute, you go to your cluster, and there are libraries. In the libraries, you can go ahead and install it. In this installation, you can go ahead and select the workspace, your PyPy or Maven. So let's say I want to go ahead and install a package called OpenPyXL. Okay, so in this, if I click on install, it is going to install that, and you can use this particular package across all the notebooks. Hope you have liked this video. So hit the like button, subscribe to my channel, and share it with your friends as much as possible. Thank you so much for watching, and I wish you have a good day.